we'll start this off. So the first thing I want to do, I'm just going to zoom in on the first couple columns here and cells so we can see things a little bit easier. You guys don't have to do this. But what I want you to do here in the first cell is just type in RAND. So there's going to be this first row is going to be our headers. Okay, so there's going to be titles. So then, yes.
Is this on the one that you have?
This is a new one. This is just, and so I'm in Excel here. You could do this in Google Sheets as well, in a separate Google Sheet. The commands are for Google Sheets and Excel are very similar. They're different. Google Sheets is Google or Alphabet, and Excel is Microsoft, right? So they're not the same companies, but their structure is very similar, and their commands are similar. So what I want to do is basically we're going to generate a way for Excel to flip a coin for us. Okay, and we could do this with rolling dice as well, but flipping a coin is easier because there's only 2 outcomes. But flipping a dice would not be all that difficult. But if I want to flip a coin, how many outcomes could I have? And what are those outcomes? 2, and they are
heads and tails.
Heads and tails. Okay, so what I'm going to do is I'm going to ask this right now to do that. So if we hit equals and now type in rand between. Okay, so what it's going to do is it's going to choose a random number, and it's going to be between 2 values that I give it. Okay, and it picks off the integer. Okay, so it's not going to give me like a decimal. And we could do, I think rand, just RAND, or it might be random. There is a function that will give me a number between 0 and 1 if I wanted it. Okay, but I just want to go 0, 1. And what that's going to do is it's going to randomly choose either a 0 in that spot or a 1 in that spot. Does that make sense? So when you hit enter, some of you're going to see that it populates a 0, like mine did. Some of you got 1, right? Totally random on what you got. Does that make sense? So is that kind of like flipping a coin one time? Okay. So now what I want to do is I want to name that. Okay. So let's say, let's just type outcome here. I'm going to hit equals. Okay. So in geometry, we talked a lot about if-then statements, right? And my hope was in geometry early on, I kind of conveyed to you that all of mathematics is built using if-then statements. All of our theorems, all of our rules, even though if they're not presented as if-then statements, they can be rewritten or restructured as if this is happening, then you do this, or you have this approach, this process that can be followed. We're going to write, so a lot of our computer programs that we generate, I don't want to say all, a lot, I'll say all of them, are structured using a series of if-then statements, okay? And this is one, maybe the first ones that we can really see this happening here. I'm going to type in if, okay? And basically what I'm going to do is I'm going to tell this cell to do 2 things, okay? And it's going to be based off of what I see in this cell right here. So if I type in if, and I'm going to click on that, okay? So it says if A2, and I'm just going to hit equals, okay? And now all I have to do is decide, well, what do I want this thing to be? Basically what we're trying to figure out is, if it's a 0, I want to name it heads or tails, okay? If it's a 1, I want to name it the other thing, okay? So let's just say if A2 equals 0, okay? If that's the if part, if that is being met here by this cell, then, okay, so a comma is going to take place of the word then. We want Excel to return the word heads. Okay. Now, with this if statement, and this is the way they're built, is at least in Excel, is that's what it's going to do. Heads is, you see right here, and if yours is still written there, I know it's kind of hard to see on my screen, but it says when you type in the word if, and then asks you what's the logical test. So the logical test is what is happening here. It's the A2 equals 0. Does that equal 0 or does it equal 1? If it equals 0, the value of true, okay, so if it is true, this value is going to be sent back to me. And now I hit comma, and you see that it says, now here, what is the value with false? Well, if 0 is my option or 1 is my option, but if it comes back as 0, it gives me heads, what is my option if it's going to come back false? I should ask it to say tails. So I put in parentheses or quotations tails. And then hit enter once you have it. And you should then get one of those words to come up. If you got a 0 in your cell, it should say heads. And if you've got a 1, it should say tails. Now, there should be a place. I'm not sure where it's at. Let me see if I go to. Okay, you see where it says formulas up here at the top. Over here where it says calculation options. Basically, and you'll notice this as we go through some of this. Every once in a while, when you hit like enter or you do a procedure, it will regenerate this and it'll change this to a 1. It'll rerun that calculation. If you want to do that on your own without having to really impact anything else that's going on in your sheet here, is you can go to formulas, and over here where it says calculation options, one of these buttons, you see where it says calculate new, I can click that and it will start to essentially, every time I click it, either go from 0 or 1. Does that make sense? Okay. And you can actually set up rules that will recalculate your formulas when you want it to. All right. Let's do this. Let's count. I'll just say H, so count heads. Okay, so now what I want to do is I want to basically, what's going to happen here is that we're going to drag these down eventually. So we'll do a second flip, a third flip, and a fourth flip, and a fifth flip, and on. And basically, I want to determine how many heads are here in this column. Okay, instead of having to go through and systematically counting them. Does that make sense? Or counting them by hand. So what I'm going to do is I'm going to say equals, and then count if. Okay. And now it says, so I count if, and now basically all I'm going to do is I'm going to say, what is my range? So I'm going to say count if, I'm going to go B to B. Okay. Now usually when you are asking it to count off of a basic criteria, you don't want to choose the entire column. But because I'm going to ask it to look for a string, which a string is just a list of characters. It's words. They don't have to be words that mean anything to us. So I'm going to ask it to look for this string of heads in this column. Okay. So because I've got outcome highlighted, it's not a big deal because it's going to read outcome, that string, and say, well, that's not heads, so don't count it. Does that make sense? Okay. So some people say, well, why the whole column and why not just B2 to like B 10,000 or 1,000? Okay. Well, that'll work as well. Okay. But that would limit me on being able to, flip this coin more than 1,000 times. Okay. So I'm just going to go B to B. And then I'm going to type in comma, and now the quotation. Okay, so Excel, the quotations in Excel indicate that it's going to start looking for a string. So basically what it's going to do is it's going to look through this column, every cell, and if it has that string matched up in any of these cells, it will tally it and it will count it, the total. So once I hit enter, okay, it's going through here, and right now we see that I have no heads in here. So that's why it gave me a tally of 0, right? Okay. So now let's count tails, which there's going to be multiple ways of doing this. We could, if I've got heads and I've counted those, could I take the number of rolls that I've done or number of flips that I've done and basically subtract the number of heads? So if I did 8 of these or 7 of these and I got this number to be 3, 1 at 7 minus 3, give me that count. Does that make sense? Okay. Or we can just be basic and bland with it and just type in count if. I'm going to go through B again and look for the string tails. But you can be, some of these you can be kind of creative with and creating the formulas, different ways of doing it. Okay? So we've got that. Okay? Now what I want you to do, I want you to come over here where it says A2. Okay, and I'm going to move my cursor down to the bottom right of that cell where it turns into a kind of solid black cursor. And just drag that down to A5. And it should then drag that formula into those things. So basically what it's done is it's flipped my coin 4 times. Does that make sense, everybody? Okay. Then you just go to the rest of these. All right, I guess you only have to do the outcome because these are just keeping our count. And you should get that if statement to copy into these cells. Is that okay with everybody? Just make sure you've done this correctly. Every time you see a 0, does it say heads next to it? And every time you see a 1, does it say tails next to it? Okay. So now what I want you to do, so you now, and we're just going to deal with this one here. We're just going to count our number of heads that we have. Some of you, and we maybe can see this with this situation. So right there, did anybody get 4 heads and 0 tails? Okay, so we get a situation where we do, so this is experimental probability, and we get 0 tails. But we know theoretically we should have gotten 2 tails, right? Okay, some of you might have gotten 2 and 2, that's matched up to theoretical. But some of you might have gotten 3 and 1, right? Okay, so what I want to do right now is I just want to, instead of you guys individually trying to figure out this, let's consider like you as an individual, you now have a sample of 4. Does that make sense? Okay, because you just did 4 flips. Let's merge those into a classroom. Okay, so what I want to do, and I'll explain this in a little bit more detail once you guys fill this stuff in, but go now to the Excel sheet or the Google sheet, and we're going to I've got your names over here. Don't mess with your names. And just right now in this B column, this blue column, all I want you to do is type in the number of heads that your Excel sheet gave you. Okay, so mine was 3. And then hit enter and just leave the rest of them alone. No homework. So what's going on here is when we take our individual sample of 4, okay, and now we look at the collective group, okay, there's going to be, so we got what, 15 people here? So there's going to be 45 now in my sample, right? Okay, so it's as if maybe we did we talk about these like pharmaceutical drug research problems and that kind of thing, or studies where if I have a group of 15 people and I give them a drug and 8 of them get better, and that's all that have ever received this new drug, is that really enough to say that my drug is above 50% effectiveness? Okay, or should I get more sample or a larger sample space and conduct the study again, right? Does that make sense? So collecting these all together is hopefully getting us to see that the sample space is growing quickly here, okay? So we don't have, so Brooklyn's not here. What are we waiting on, Lex? You typing in? Yeah. Did you hit enter? Jeez. All right, so I'm going to come over here now and say, okay, so that totals. Okay, what I want here is I want the sum of B2 through B16. Okay. We'll just delete Janet as well. So B2 to sum B2 through B15. And I could actually do the whole column if I wanted to. And what Excel does is if it sees a blank, it will ignore it. Does that make sense? And if it's a sum, it's just 0 anyway, so it doesn't matter. Hit enter, and now we've got 26. Does that make sense? Okay, and that should hopefully, if we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of us. Okay. 12 times 4, so I'm trying to figure out my sample space. Okay. Now there is another way, and I just to show you guys this, instead of counting, how many things did I have here? Excel has a nice feature that says I hit equals. Let me zoom in so you guys see this a little bit better. All right, so if I hit equals and then I go count A, okay, what this is going to do is it's going to search through my cells that I provide in the array. So I'm just going to say A to A, so that means the whole column. So it's going to look at the entire column A right here, and if there's something written in it, don't care what it is, as long as it's got a single character in it, it's going to count it. All right. So if I do that, it gives me a sample space of 13. Okay? Now, how many people are in this room right now?
Too many.
Counting me, there's 12 of us, right? This number is 1 too big. Why is this number 1 too big? Because the title. So how can I adjust that? I could fix it, say, now here's the thing, and there should be a way that I can just go A2 all the way through the end, but I'm just going to say -1. Won't that fix it? Okay, so now my sample space, that's just 12, but what did each one of us roll? How many times? 4. So I'm going to put out in front of here 4 times my sample space, and now I get 51, right? Okay, so 13 of us rolled 4 times. Okay. Ooh. No, that's right. No, I've got that wrong. So it should be, because what's this doing? It's taking, because where that 4 is, I need another set of parentheses here. So it's taking 4 times 13 and subtracting 1 from that, right? We want 4 times the quantity, 13 minus 1. So it should be 48. We're cool with that? Okay, 12 of us rolled 4 times, 48. All right, so based on our particular situation, heads came up 54% of the time. You got 26 heads out of 48 total rolls 54 times. Okay, next thing I want us to do, go back to Excel, and all I want you to do is drag this down to A11 now. And then drag the B2 cell down to A11 as well. Gather the heads number and go plug that into the Google Sheet in the red column. This is kind of what I was talking about yesterday, and it's very rare to happen. Because these events are independent events, which we'll get into later on. So if I flip a coin, I don't have any coins. If I flip a coin and it lands heads, does that outcome impact me flipping another coin and what it's going to land? No, right? Okay. And that should contrast to, like, if I gave you a deck of cards and I said, pick a card out, okay, and put it in your pocket. Now what's the probability on your second pull that you pick an ace out? Is that second pull dependent on what was in your pocket? Yeah, so those are dependent events. So when I try to determine whether events are dependent or independent of one another, that is one way I think about it. Now, there are some mathematical formulas that allow us to determine independence or dependence as well. But if events are independent, okay, and what we call mutually exclusive, so they cannot happen at the same time, so heads and tails cannot happen at the same time, all we have to do to find the probabilities is to multiply them together. So if I want to know what's the probability of getting, flip a coin, get heads, and then flip another coin and get heads, okay, well, it's 1/2 the first time, it's 1/2 the second time, multiply those together, you get 1/4, right? So the probability of getting heads back to back is 1/4. So the probability of getting heads back to back 10 times would be 1/2 times 1/2 times 1/2 times 1/2 10 times, right? So that's 1/2 to the 10th power. Okay. You saw when I was doing the calculations, I had 0 4 times. So I think it gave me, I don't know which one it was, heads or tails. It gave me 4 of them. Well, that's 1/2 times 1/2 times 1/2 times 1/2. That's 1/64. Does that make sense? Okay. Is that right? 2 times 2 times 2. No, 1/16. Sorry. Which is a pretty low probability that's going to happen. If I went and did, I said yesterday I did this, and I dragged it down 10 rows, and it gave me 10 zeros. Okay, that's 1/2 to the 10th power would be that probability. Very, very, very unlikely to happen. I could probably sit here all day long, and that never happened again. Okay, and recalculating on the second, and it probably wouldn't happen. Okay, but I think most of you probably got in the ballpark. Anywhere, anybody get like 8? Anybody fill that in? 8 or 9. I got a 7. Okay, that's my highest. So now I'm gonna come over here to the totals, wherever they went. There they are. And I'm just gonna cut and paste this formula. Okay, but I don't want the sum between B2 and B15 because now it's C2 and C15, right? Okay. And we'll take this formula and we'll paste it, but I don't want 4 times the count. I want 10 times the count, right? Okay, because we all did 10. We got 120 rolls, we have 53, so now 53 out of 120 is 0.44, right? Okay, and this can happen, but what's going to happen here is that you see that these are not quite the same, right? They're not quite what we expect out of our theoretical probability. And right now, the reason for that is that these sample spaces are pretty small. And with small sample spaces, there's more fluctuation. Fluctuation. I don't know why I want to change everything to have the ITY on the end of it. I don't know. Okay, whatever. Let's go to the Excel sheet, and now this is where it gets kind of messy. There is a command, I don't know what it is off the top of my head, that I can fill the rest of this column as far as I want to with this formula. But the easiest thing is just to, I think I can maybe do these both at the same time. If I highlight both these and drag down, just want to make sure that it will, so grab both those and just drag straight down and go to 51. So that would be equivalent to each of us rolling 50, or not rolling, but flipping the coin 50 times. And mine turns out to be almost 50-50. I got 24 heads. Okay. Anybody get 25-25? Okay. So then now go into the Google Sheet and just type in your value there. 24. You were doing that, I'll fix the formulas over here. Okay, so we've got all 600 of us, each of us, 12 of us, 50 flips, 600. We fill those in, and we see, okay, so this one started us above 50%, this one dropped us down below 50%, this one is now moving that closer to 50% from the bottom of 50, right? Okay, let's do 1,000. So just come down to 51. You're gonna click and drag and just keep dragging. Let's do more than 1,000. How many you want to do?
10,000.
That'll be waiting here for a long time. What if we go?
10,000.
What if we go 2,500? So we're about to 2,501.
Mine's already like last time I just got it.
That means your formula and that's the one that was dragged.
You know, good. Another shit
Oh, that's because, so we've identified 0 as head, right? So you gotta drag that one too. So does it seem that this cell is vacant? So it attaches the number 0 to it. So if I fill this,
That's what I had there.
Excel substitutes with it. So drag that. I said, okay. So drag. So if you click both of these and that, and now pull that down. So it's dragging both those.
No, that was for 1,000.
Okay.
Makes sense?
Yeah.
Good.
Well, yeah, but I already had 1,000 done.
All right, so I just did 2,500 on my own, and what's half of 2,500? 1,250, right? Okay, so I am seven flips from being dead even. Okay. Did anybody else get that dragged all the way to 2,500?
Well,
I mean 2,501 actually.
From 1,000, mine was 501.
We did 1,000 in the first class, and somebody had 500. Okay, so the idea is the more that you do, the more, or the closer this thing becomes 50-50. All right, so I'm gonna put mine in, and then I'll come around and, a lot of you already got them. 12, what was my 43? So the idea here is, and as you guys continue to fill yours in, mine was 7 under the halfway, okay? Kenna's was 7 over. So what do ours, my underestimate and her overestimate, what are they doing? Cancel each other out, right? And that's the idea. The more tosses that we get, the more flips that we get, or if we're, rolling dice or something like that, those probabilities are going to negate each other. Some are going to be overestimates, some are going to be underestimates, and they negate each other. So now that we've got all those filled in,
I won.
I'm going to come over here. And so we've got now the sum, what was it, E2 to E15. Just want to make sure that's correct. Yeah, all right. And then we would have been equals 2,500 times, count A minus 1. So I get that, right? doesn't. So we all did 2,500 times count A to A. There's 12 of us, right? Yeah, but I deleted hers, right? Is there somebody else that's not in here? All right, looks like we're on. So we've got 30,000, and now okay, so 30,000, and we got 15,147. If we divide those, pretty close to being 50-50, right? Now, this is only, so if we go through and I think what I've got here is this is adding up all of these that we've done. Okay, so all 26, 53, 284, 15,147, and then dividing by the sum of here of all these added together, and it's even a better approximation. Does that make sense? Just kind of demonstrate here, if I go, clicking and dragging mine for some reason is a little bit faster. And as we work with, and I know it's, Excel is not going to be an everyday thing, but if you're working with it on your own, I think Excel with your touchpad on your keyboard is a pain in the butt because a lot of the click and drag and that kind of stuff that's useful, like a real mouse is very handy, especially if it's got like a scroll wheel.
No, my fingers can't go.
Well, if you're going to cut your finger off later, shouldn't matter.
Why would I cut my finger off?
No, we
That's what we were talking about yesterday.
You're not thinking logically, Mr.
Well,
Tim.
I want to tell that pinky. Pinky or ring.
No, you don't cut your finger off. You get it cut off in a freak accident.
Oh, you don't do it
Oh,
intentionally?
yeah.
No.
All right, so
It's like you've got like gun to your head, they're cutting off one of your fingers and you're dying.
so I have 5,000 flips by myself, 5,000 flips, and we're
Wow.
11 off of being dead even, right? Okay. So now if we all did that, okay. So when I have 5,000, okay, that's essentially saying that that's one sample size of 5,000, and that's an individual study. Does that make sense? Okay. So let's say that I have I'm a pharmaceutical company, made this drug, and I want to test its effectiveness. I do a study of 5,000 people. Okay. Let's say Lucas takes the same drug and he now samples another 5,000 people. Okay? Lex does the same thing. Bella does the same thing. John does the same thing. So now we've got 5,000 times like 6, right? When we go look at the collection of his study, my study, Lex's study, John's study, Bella's study, and we analyze all the data from each of those studies, it's called meta-analysis. Okay? Collecting data from a bunch of already predefined studies. And that's really what we're doing here. Okay? Individually, we looked at your 4 flips, your 4 flips, your 4 flips, and then we combine them, right? And they said, okay, well, if I did 4 flips, but 12 of us did that, that's 48. Okay? That analysis of that 48 and how many heads or tails came out of that 48 is called meta-analysis.
Right, 1 second, I'm going to do 10,000.
Okay. But the high, so my hope is that you're seeing here is that individually, okay, very low chance that I'm going to get, 5,000 tails to show up or 5,000 heads to show up, right? Okay. And even on the short term, if I'm going to flip it 10 times, I might get 7 and 3. On 20 times, I might get 13 and 7. Okay. But if I do it in the long run, and 5,000 really isn't even the long run. Okay. Because 5,000 is a pretty small number in regards to where we can go with it, right? Okay. And when we were doing the entire group's data, we got up to 30,000. Okay, that's a pretty large number. The higher the number of samples we get, the experimental probability, that's what this is right here, what is that getting closer and closer to? 50%, which is if I'm flipping a coin, instead of the experimental probability, 50% is the theoretical probability, right? Okay, so I'm actually doing the flipping, that's the experimental. And that was dragging and determining, letting Excel create heads or tails for us. Okay, so that was the experiment. Theoretical says we know based on mathematical calculations that heads has a 1 out of 2 chance showing up. Okay? The law of large numbers, okay, comes into play. So would you guys agree that that's a large number? Okay? So the law of large numbers says the more you have in your sample space, theoretical probability and experimental probability are going to do what to one another? They're going to become equal. Okay? They're going to converge. Okay? Have you ever, those of you who play sports, okay, softball, baseball, somebody's a 300 batter, okay, so they get hit every 3 times, or 3 times out of every 10 that they go to a plate. And let's say that they're in a slump, they've gone 0 for the last 30. What do their teammates always say? They're what? They're due for a hit, right? Because the law of large numbers says if they're a 300 batter, they've demonstrated over a period of time that they're a 300 batting average, then the law of large numbers says, okay, they've gone 30 hits or 30 at-bats without a hit. Their law of large numbers says they're bound to get their hits here pretty soon. And usually what happens if you're a 300 career hitter and you've gone 0 for 30, usually what happens then, and you go for like 9 for 9 the next set of at-bats, okay? Usually, unless you just completely end your career and you just start really being just crap awful. If you're a career 300 hitter, you usually recoup that. You come out of that slump and you go study all the Major League Baseball hitters, Major League softball players, all that kind of stuff, college softball, college baseball. Those trends exist, okay? And it's the law of large numbers that allows that to happen. Does that kind of make sense? All right. And we'll use this idea to do or analyze our studies. And then I talk about like drug pharmaceuticals. I think that's something that it makes sense and it's easy to think about. And we're able to see like explanatory variables easy and response variables easy out of those situations. But if I do a study of a new vaccine and I only have 20 people in my study and 10 of them get better, is that really enough to say it's a 50% effectiveness? No, I've got to do more, okay? And the idea is even though that theoretical, with a vaccine, that theoretical probability is unknown, okay? It will never be known, okay? But the idea that it's there, and the idea of law of large numbers says the higher you get with your sample space, then your experimental and your theoretical should merge. If I get a high enough sample space, even though I don't know what my theoretical is, my experimental will merge to it, and my experimental will eventually tell me what my theoretical is. Does that make sense? Okay, so that's kind of what we'll do with studies and some of the problems that we deal with in regards to probability as we move forward. All right, but the main concept here is hopefully we can see in the long run, law of large numbers takes experimental probability, theoretical probability, and they merge. They become the same number. Okay.